So this is my mid-unit 6 assignment solutions. So I will be going over my solutions for the questions. And to begin, in the first question, what do you think the relationship is between pH and the amount of acid? Explain using your results. So my solutions is that the pH level stayed the same no matter the quantity of an acid, because when my beaker had 10 milliliter, the pH level was 2.5, and it still stayed the same when there was 20 milliliter in the beaker. And moving on to the second question. Now note down the concentration of H3O and OH and the pH. Add enough water to the acid to make a 0.5 liter solution. What do you notice happens to the concentration of H3O and OH and the pH? So my initial pH level was 2.5 and my final pH level was 4, and my initial hydronium level was 3.2 to the times 10 to the power of -3, and my final hydronium level was not level, but my final hydronium ions was 1 times 10 to the power of -4. And moving on, my initial hydroxide ions was 3.2 times 10 to the power of -12, and my final amount of hydroxide ions was 1 times 10 to the power of -10. And I noticed that when I added water to my soda, I diluted it, which decreases the concentration of the hydronium ions and hydroxide ions while increasing the pH level. Moving on to the third question, I calculated the final hydronium concentration to be 1.25 times 10 to the power of -6, and I calculated the final pH level to be 5.9. Now add enough water to the solution to make 1.2 liter and determine the values for hydronium concentration and pH. Compare them to your calculated results. How do they compare? Okay, so this is very interesting because after adding enough water to dilute the solution, I have found out that my calculations were close to the actual results, being a pH level of 5.88 and a hydronium concentration of 1.3 times 10 to the power of -6. And so moving on to question 4, while we are neutralizing acid with water, what is an alternative method of neutralizing an acid? Explain the reaction that takes place in the products that form. So an alternative method for neutralizing an acid is to actually just add a base, and the reaction between an acid and a base is called neutralization reaction, and this reaction will just either result in either water or salt. So moving on for question 5, my solution is a train declogger is usually very basic with a high pH around 12 to 14 and a very low hydronium concentration. This strong base actually helps break down tough clogs like hair and grease without damaging metal pipes, and the high pH shows it's effective on organic matter but also safe for pipes. So moving on to the next question. When I empty my beaker and I fill it up with 0.5 liter of train cleaner, what do I notice about the pH and hydronium concentration? So I noticed that the pH is 13 and the hydronium concentration is 1 times 10 to the power of -13. Next, when I empty the beaker again and add 0.25 liter of milk, slowly add water to the milk and note the pH change. What trend do I observe in the pH change? I actually noticed that the pH increases. And my solution for question 8 was that the solution's pH is likely between 5.5 and 6, since for most cereals, green turns blue when the pH is 5.5 or higher. So the solution must have a pH of at least 5.5. And also, methyl red produces an orange color when the pH is between 4.8 and 6. This shows that since both indicators work between these ranges, the pH of the solution is most likely between 5.5 and 6. This concludes part 1 of my mid-unit assignment, and thank you for listening.